1. Two identical circular loop of metal wire are lying on table without touching each other. Loop A carries a current which increases with time. In response, the loop B. So if you see when the current will increase, so let us talk about the direction of the induced current. If I say this is the loop A and this is the loop B, right? And it is said in the question that the in loop A the current increases with time. So when the current will increases in this loop with time, then what will happen? Let's say the current is in this direction, then if you will curl your finger, then you will get the flux in upward direction. So if the flux here is in upward direction, then you can imagine the flux in this loop will be inward because it will be going like this, right? So here the flux will be inward. So here I will write the flux is upward. Here it is inward. So if the upward flux increases with time in loop A, then the inward flux will increases in time with time in loop B. So if I talk about the induced current in B, so induced current in B will be such that it could it could oppose the change in flux. So how can it oppose the change in flux? By generating a current in the same direction. Because if the current will be in the same direction, then the flux will be in upward direction. If the flux will be in upward direction, then only it could resist the inward flux increase. So basically this will be the case, right? And if I talk about the attraction and repulsor force between the loop, so if you see the current direction in the adjacent wire, so here the current is in upward direction, here it is in downward direction, so they will repel each other. Because the current is in opposite direction. Now you can check is repelled by loop A, so C will be the correct option. Simple. Thank you.
Hello everyone. A vertical iron rod has a coil of wire wound over it at the bottom end. An alternating current flows in the coil. The rod goes through a conduction ring as shown in the figure. The ring can float at a certain height above the coil. In the above situation, the current is induced in the ring which interacts with the horizontal components of the magnetic field to produce an average force in upward direction. So the question has given us two statements and is asking if both of them are independently true and if statement 2 is correct explanation of statement 1. The current passing through the coil will create a magnetic field in the space. And due to this magnetic field, there will be a flux linked with the ring and it will produce some EMF that will be induced EMF. Therefore, this is how the current will flow. And it will interact with the horizontal component of the magnetic field produced by this coil, and that interaction will induce a force that will be net force upwards in the direction. Thus, we can write that, and we know the direction of the thrust will be upwards because the Fleming's left-hand rule applies here. Therefore, from this explanation, we can say that statement 1 and statement 2 both are correct and statement 2 is correct explanation of statement 1. So the answer is option A. Thank you.
हाय गाइस, यहाँ पे क्वेश्चन दिया हुआ है. इस क्वेश्चन में बोला गया है वर्टिकल आयरन रॉड हैज़ ए कॉइल ऑफ वायर बाउंडेड ओवर इट over the bottom end. An alternating current flows in the coil. The rod goes through the conducting ring as shown in the figure. The ring can float at a certain height above the coil because, and this is the statement 1. Statement 2 is in the above situation the current is situated in the ring which interacts the horizontal component of the magnetic field to produce a force acting in the upward direction. ठीक है, तो देखिए इसमें क्या होता है. जब इस कंडीशन में क्या होगा, इस कंडीशन में होगा कि due to induced current in the coil, द फोर्स बिटवीन टू कॉइल इज जनरेटेड। ठीक है, इन दोनों जो हमारी जो दोनों कॉइल है इनके बीच में क्या होगा, फोर्स जनरेट होगा। तो उससे क्या होगा, करंट इज इंड्यूस्ड इन द रिंग विच इंटरेक्ट्स द हॉरिजॉन्टल कंपोनेंट, यानी कि स्टेटमेंट 2 भी सही है और स्टेटमेंट 1 भी सही है। ठीक है, एंड वी कैन से स्टेटमेंट 1 इज द करेक्ट एक्सप्लेनेशन ऑफ स्टेटमेंट 2। सो ऑप्शन नंबर फर्स्ट इज द करेक्ट आंसर। थैंक यू।
Hello everyone, let us start with our question. In this question, what is given? So there are two processes which has been depicted. Now in the process one, this is the circuit which has been given. Now in the process one, the switch is closed at and the capacitor is fully charged to a potential V naught. Okay, the time for which it has been charged is very greater than RC. Now in the process, some heat is energy is dissipated across this resistor, and the amount of energy finally stored in the this fully charged capacitor is EC. The amount of energy stored here is EC. Now there is another process. So this is the process 1 in which we have supplied a V naught to be the constant voltage. Now in the second process, it is supplied to, first it is supplied to V naught by 3 voltage, then it is connected to a battery having a potential V naught by 3, 2 V naught by 3. Okay, the time for which it has been done, it is very greater than RC. Now the process is repeated one more time by raising the voltage to delta V. So first of all, the potential is V naught by 3, then 2 V naught by 3, then V naught. Now what we need to find? We need to find in the process 2 the total energy dissipated across the resistor ED is. We need to find what is the total amount of energy dissipated across the capacitor. Okay. Now we can do it in multiple ways. So one of the way which we will be doing, for example, this is the first situation. Okay. This is the first situation. This is our battery, and let's say this is the capacitor. So it is basically time is given is greater than time is given as to be greater than RC. So that means this circuit would be just an open circuit at this time. Okay, so the whole of the there won't be any current at this time. Okay, so we can just draw our capacitor like this, and there would be a resistor, but we are not drawing because there would be no need to define it. Even if we have defined this, for example, like this, let's say in the initial case, what has been done? In the initial case, V naught by 3. So what would be the charge when time is greater than RC? So it would be becoming as a open circuit. So what would be the charge stored? Charge is given as Q. We just write the value as C into V. So what would be the charge stored here? It would be C V naught by 3, and here it would be C V naught by 3 minus, and this would be the plus sign. Okay. Now what is the charge which has been flown from this battery? It would be C V naught by 3. So we can say that the energy this dissipated across the capacitor would be what? So first of all, we write what is the work done by the battery. So work done by the battery, this is our case 1. What would be the work done by the battery? It would be equals to this potential multiplied by the charge flown, Q into delta V. So the charge flown is C V naught divided by 3. So this term would be equals to C V naught square divided by 9. Okay. Now what would be the change in the potential energy of the capacitor delta U? It would be equals to UF minus UI. Okay. Now initial value would be equals to 0. So what is the final value? It would be equals to, because U value, we just write the value for the capacitor. U is equals to 1 divided by 2 CV square. This is given for a capacitor. So we can say that UF would be equals to 1 divided by 2 into C into what is the final this value of the voltage. So it is given as to be V naught by 3. So we can just put the value of voltage as V naught by 3 square. Okay. Now initially there was no charge, so minus 0. Okay. So this value would turn out to be C V naught square by 18. Okay. This is the work done by the battery. Now this is the energy which is stored in the capacitor. So these are not equal. That means there is some portion of energy which is dissipated. So if we just subtract these two things, we will be getting the energy which is dissipated in the resistor. We call this value as D1. So it would be C V naught square by 9, which is supplied by the battery, minus C V naught square divided by 18. So this value would be C V naught square divided by 18. So this is the value. Okay. Now in the second case, what we are doing, the potential supplied is equals to 2 V naught by 3. So we just draw our second circuit. So case 2, this is our case 2. So we just draw our circuit. So this is our capacitor, and this is connected to a battery. Okay, like this. And we are just drawing the resistor, but we are just waiting it for the after a long time. Okay. Now what will happen? So in the second case, we are supplying 2 V naught by 3. So after a long time, what is the charge which is developed here? It would be positive, it would be negative. So it is C into V. So capacitance times the value of this this voltage value. So it would be equals to 2C V naught by 3, and here it would be 2C V naught by 3 after a long time. Okay, and this is plus, this is minus. Now initially what was the charge here? Initially what was the charge? it is equals to CV naught by 3. Initially this was the charge, and finally what is the charge? It is 2 CV naught by 3. So what is the charge which is flown through this part? So it would be CV naught by 3, the final charge, minus the initial value of the charge, which was CV naught by 3. So if we subtract these two quantities, it would turn out to be, which is the charge flown by the battery, CV naught by 3. Now if this is the charge, what is the work done by the battery? So work done by the battery would be the potential of the battery to V naught divided by 3 multiplied by the charge flowing through the battery, which is equals to C V naught by 3. Now this also turned out to be, this value would turn out to be 2 C V naught square by 9. Okay. Now here also we can find the value of our delta U. Now delta U would be equals to UF final minus UI initial. So what is the value of the final energy which is stored? Half into C into V square. Now what is the potential? 2V naught by 3 square minus what was the initial potential. So initial potential would be equals to, we have already calculated, this value was, this value turns out to be CV naught square by 9, because initially this was 0. So UF value would be equals to CV naught square by 18. So this final value for the first case would be the initial value for our second case. So it would be just equals to, or we can just write the value 1 divided by 2 into C. What was the initial voltage which was applied? V naught by 3. So it would be half CV square. Okay, if we calculate this, so this would turn out to be 3 times CV naught square divided by 18. Now this is the energy which is supplied by the battery. Now this is the energy which is stored by the battery. So what is the difference? So if we find the difference, ED2, this would be the energy which would be dissipated by the our resistors. So this value would be equals to, we take the difference, 2C V naught square by 9 minus 3C V naught square by 18. So this would come out to be again C V naught square divided by 18. Now after that what we are doing? Now after that we are just connecting it to a voltage of V naught. So if for the third case also we draw our circuit for the third case. So this is our case, this is the capacitor and this is the resistor. Okay, let's say this is our battery. Now here after that we are making it potential to be V naught. Now after a long time what will happen? This is the positive, this would be the negative. After a long time what would be the charge here? It would be capacitance times the potential. So C V naught. Here it would be C V naught, but here it would be positive, here it would be negative. Now initially what was the charge if we compare with this situation? It was 2 C V naught by 3. Now it is what? It is equals to C V naught. So what is the difference? C V naught minus 2 CV naught by 3. Now this would be the difference, which is the charge which is given or which is thrown from the battery. So if we take the difference, it would turn out to be CV naught by 3. Now if this is the charge which is flown by the battery, then what is the work done by the battery? It is equals to potential time the charge flown. So it is V naught times CV naught by 3. So it would turn out to be C V naught square by 3. Now what would be the delta U? That means the change in the potential energy of the capacitor. So if you find the change, it would be equals to 1 divided by 2 into C into V naught square minus 1 divided by 2 into C. What was the initial voltage? It was 2 V naught by 3. So 2 V naught by 3 square. Okay. So if we calculate this, so this would turn out to be C. Sorry, this would be 5C, not C, but 5C V naught square by 18. 5C V naught square by 18. Okay, now what would be the, so this, there is a difference between the battery and this, so it would be going to the resistor. So ED3, we calculate this value if we subtract CV naught square by 3 minus this value 5 CV naught square by 18. So this will again turn out to be CV naught square by 18. Okay, so what is the total energy which is dissipated in the this ED total if we find? So it would be ED1, ED2, ED3, but each of these values are same. So we can just multiply 3 with these values. So it would turn out to be CV naught square by 6, or we can write this as 1 divided by 3 times 1 by 2 CV naught square. So which option would be the correct option if we check our options? So the correct option in our case would be our D option. So 1 by 3, 1 by 2 CV naught square. Hope you have understood the solution. Thank you.